So next topic in the module 1 is eigenvalues, eigenvectors, and Cayley-Hamilton theorem. These three are common, not a separate topics. These three are combined together. So what is a eigenvalue and eigenvectors? So eigenvalue, nothing but a constant. Usually it is a scalar. Here I provide the definitions. I think you know little bit in your BSc level. Lambda, the scalar lambda belongs to some field. Usually the field element are called scalars, is called eigenvalue of a matrix A if A into some column vector equal to lambda times of column vectors. After multiplying A with some non-zero column vector, here x is non-zero. You remember that non-zero column vector. If there exist non-zero column vector such that Ax equal to lambda x, then lambda is called eigenvalue or latent value or proper value of matrix A, eigenvalue of A. Here x is called eigenvector, or latent vector or proper vector, eigenvector corresponding to eigenvalue lambda. This is the definitions, usual definitions. Here, for the problem solving purpose, I give in different manner. If A is a square matrix of order n, we always taken in the eigenvalues, eigenvectors, and Cayley-Hamilton theorem, we are always consider a square matrix because we want to det. Det only exists for square matrix. Square matrix means number of rows equal to number of columns. A minus lambda I. We can form the matrix A minus lambda I is the identity matrix of same order. The determinant equal to 0. We get a polynomial in lambda whose order is n. This is called characteristic equation, CR equation, characteristic equation of the matrix, given matrix A. The roots is called eigenvalues or eigenvectors. The roots of this determinant are polynomial. A minus A is a square matrix of order n. A minus lambda I is also a square matrix of order n whose det equal to 0. Then we get a polynomial in lambda because lambda is a variable quantity. A is a n, this is a n by n order matrix, so we get a nth order polynomial in lambda. So this polynomial is called characteristic equation. Equal to 0 means it is equation called a characteristic equation of the given matrix. The roots of this equation or polynomial is called characteristics values or characteristics eigenvalues or characteristics values of the given matrix A. This is the basic definition. Eigenvalues. So whenever we want to find eigenvalues, immediately you make A minus lambda I whose det equal to 0 and solve this equation. We get a eigenvalues. This is the procedure to find eigenvalues of the given matrix. Eigenvalues easy. Later finding eigenvectors, it takes some time. We apply the previous methods. So row echelon form, reduce the echelon form, consistency, inconsistency, system of equations. We go for backs of previous concepts, solving system of equations whenever we want to find eigenvectors. Up to eigenvalue easy. We get a polynomial, solve the polynomial equation, we get a roots. Those roots are called eigenvectors or eigenvalues or characteristic values or latent values of the given matrix. Eigenvector corresponding to eigenvalue. For example, lambda is one of the eigenvalue. Corresponding to eigenvalue, there exists a non-zero vector x. There exists a non-zero. You must keep in mind non-zero, not a zero. Non-zero vector x is called eigenvector corresponding to lambda of a square matrix A if Ax equal to lambda x. After multiplying A with x, pre-multiplication. Pre means left-hand side. Post means right. Pre-multiplication of A with x, we get a lambda x. And then x is called eigenvector corresponding to lambda. Procedure to find eigenvector corresponding to eigenvalue. Here I provide the procedure how to find eigenvector. So first, A minus lambda I into x equal to 0 because from this equation, as per definition, here I am writing A x equal to lambda x. shift all the values into one side or move to one side lambda x. Here you write down lambda I into x because multiply with identity matrix, the resultant value does not change. Take x is a common factor from the right. Then we have a minus lambda I times of x equal to 0. This is the first step. X, we don't know. Suppose initially you take it as a column vector x, y, z. If it is a 3 by 3 matrix, if it is a or x1, x2, x3. If it is a 4 by 4 matrix, you take x1, x2, x3, x4 column vectors. X. Later we get a system of equations. Solve the system of equation by using well-known methods. We get a column vector x1, x2, x3, x4 values. So it is always homogeneous. It is a system of equation. Right hand side all are zeros. So we always exist a homogeneous. Therefore, the system must have a solution. As per definition, homogeneous system always have a solution. Therefore, there exists a eigenvector corresponding to eigenvalue. If we have a eigenvalue, definitely we have a eigenvector. Actually, infinite number of eigenvectors are there. No need to, I am going to don't beyond. So eigenvector 1 is enough as per our procedure. So this is the procedure. First step is a minus lambda I into x equal to 0. We get a system of homogeneous equations. Solving system of homogeneous equations by using previous yesterday class procedures, we get a x vector. The corresponding x vector is called a eigenvector corresponding to eigenvalue lambda. This is the procedure. Now I am going to find eigenvalues and eigenvectors for the first problem. Here I provide the 3 problems. So first I am going to solve the first problem. Okay, anyhow, find the eigenvalues and eigenvectors problem. This is the problem. Problem 1. Okay, problem 1. You understand my handwriting? I have some problem. Okay, answer. First, find eigenvalues. Step 1, find eigenvalues. As per procedure, take a minus lambda equal to 0. Det equal to 0. A means 2 by 2 matrix. 2 rows, 2 columns. So we take I is also 2 by 2 matrix. Whatever order is there, the given matrix, you take same order of the identity matrix in the second term. Now, finally, we get a matrix of 2 by 2 order. Sum of the two matrices 5 minus lambda 4. Corresponding entries we add in the resultant matrix. It is a matrix. Now, what is the det of 2 by 2 matrix? AD minus BC. Det of square matrix equal to AD minus BC. So, as per procedure, 5 minus lambda into 2 minus lambda minus 4 equal to 0. So, expand this factorization. 10 minus 5 lambda minus 2 lambda minus 7 lambda plus lambda square minus 4 equal to 0. That implies lambda square minus 7 lambda plus 6 equal to 0. Plus 6 equal to 0. Plus 6 equal to 0. We get a second order equation. As your wish, you can apply any way. Our intention is to find lambda 1 and lambda 2, either synthetic method and minus b plus or minus square root of b square minus 4ac method. Here I am applying factorization method. Here lambda. So that implies product of two numbers is 0 only when any one of the number should be 0. So that implies lambda 1 equal to 1 or lambda equal to 6. So it is a 2 by 2 matrix. So we have to roots, two eigenvalues. Therefore, the eigenvalues are 1 and 6. Actually, the eigenvalue sum 1 plus 6 is 7. It is nothing but a trace of the matrix. Trace means sum of the diagonal. So this is the given matrix 5 plus 2. 5 plus 2 is 7. So sum of the eigenvalues always equal to trace of the matrix. This is cross verification, whether finding values are right or wrong. Next one is find eigenvectors. Step 2, find eigenvector corresponding to each one eigenvectors. So now first corresponding to first eigenvalue lambda equal to 1. Eigenvector corresponding to lambda equal to 1. As per procedure, first rule is consider a minus lambda I into x equal to 0. This system that implies a value is 5 to 41. Here 4 1 a lambda I value means 1 0 0 1 into x means column vector. It is a 2 by 2 resultant matrix, so take 2 by 2 or x1 x2 as your wish, xy or x1 x2. Right hand side 0 means it is not a single 0, it is a 0 matrix. Now the right hand side, after simplification sum of the matrix, we get 5 minus lambda 4 1 2 minus lambda times of x into y equal to 0 0. Now find once again matrix multiplication the left hand side, 5 minus lambda into x plus 4y first row, second row x plus 2 minus lambda into y equal to 0 0. Now two matrices are equal if and only if the corresponding, first of all, same order, they have same order and corresponding entries are same. So first row first element same as first row first element of the right hand side matrix. Now we have a two system of equations. Solve these two system of equation as your with any method. Here there is no any restriction. Here our intention is to find eigenvalues and eigenvectors, not a solving the system of homogeneous equation. You solve by the elementary method also. In our childhood, solving the system of equation ax plus by equal to 0, cx plus dy equal to 0. This time you multiply first, eliminate x. Eliminate x means multiply first equation with the coefficient of second equation of x, multiply the second equation with the coefficient of a, then we get acx plus bcy equal to 0, acx plus ady equal to 0. Now subtract like this as your wish, or you can apply our procedures, reduce into row echelon form like that. So once again you take into row echelon form, then apply the row echelon form, finally simplify. This is 2 by 2. No need to apply any previous earlier procedures. It is better to simplify, or for the practice purpose here I am proving row echelon form method. This is coefficient matrix. Coefficient matrix of the system. Now make by applying row echelon form, make into below 0. R2 tends to R2 minus, or it is better to take 5 minus lambda into R2 minus R2. Sorry, R1. If you have any confusion, interchange the first rows, because in the first row, you always better to make into 1. R1 interchange with R2. 1, 2 minus lambda, 5 minus lambda. If you 4. Now, next step, reduce first non-zero diagonal entry below values are zeros by making row operation. R2 tends to R2 minus 5 lambda into R1. It becomes 1, 2 minus lambda. This is 0. 4 times of 5 minus lambda into 2 minus lambda. Okay. So clearly it is a echelon form. If you have further interest, you simplify. So clearly it is row echelon form. Now it is better to simplify here. 1, 2 minus lambda, 0. What is this? 4 minus of 10 plus lambda square minus 7 lambda. Further simplify this. 1, 2 minus lambda, 0. Minus 10 plus 4 minus 6 plus 7 lambda minus lambda square. Now, once again convert this system into equations. Therefore, 1, 2 minus lambda, 0, minus 6 plus 7 lambda minus lambda square into xy equal to 0, 0. Convert this system into equations form once again. 1 into x plus 2 minus lambda into y equal to 0. First row, first equation. Next 6 minus 7 lambda minus lambda square into y. First one is 0 into x. This one is no use. From the second equation, any one of them is 0. Either this one is 0, 0 is not necessary. Either this factor is 0. That implies here I forgot, I made not a mistake. I take a complex situation because lambda equal to 1. So I did not substitute the lambda value. So that's why it takes more complex. Now, okay, easily we can solve. Here 1. Sorry, dear students. Actually, lambda value they provided. We have a lambda value. So no need to, here we get, so I am erasing one more time from this step onwards. Otherwise, you substitute lambda. It get lambda equal to 1 in the last step. That is also one way. But my suggestion is, from the starting only we substitute lambda value. It is better to decrease the number of steps in the proving the theorem. So I want to reduce number of steps. If you have, sometimes if you forgot, unfortunately, don't bother, proceed until end. In the last step, you substitute lambda value. I can proceed in this manner also. Just now I substitute lambda value, but for understanding in the future purpose for you, I am deleting one more time and substitute the value and then proceed. It is better. The next problem also we will see. Actually, I picking three problems from each topic. Sometimes polynomial roots are same. That means eigenvalues are same. But you always keep in your mind, number of eigenvalues of a 3 by 3 matrix is 3 in number. 4 by 4 matrix have 4 eigenvalues. It's enough. They may be equal or they may not be equal. But the total is order of the matrix. Number of eigenvalues equal to order of the given matrix. That's all. Okay. Now, here easy to simplify. 4, 4, 1, 1. X, Y, 0, 0. So as your wish, 4x plus convert this into 4y, x plus y. equal to 0, 0. Now we get a system of equation. Two matrices are equal. 4x plus 4y equal to 0, x plus y equal to 0. From the first equation, you observe that take 4 as a common factor, we get x plus y equal to 0. In the second equation, x plus y equal to 0. So both are same equations. So no need. If you independent equation, then only we can solve. That means x plus y equal to 0 only. Both are same equation, no need to consider two times. That implies x equal to minus y. If you know x, we can find y value. Therefore, the solution or vector, eigenvector, usually our people take x equal to 1. Therefore, that implies y equal to minus 1. Eigenvector corresponding to lambda is, there are infinite number of eigenvectors. Take x equal to, we get another eigenvector corresponding to eigenvalue lambda equal to 1 is x comma y. By taking x equal to 1, we get y value. Y value is minus 1. This is the one of the eigenvector corresponding to eigenvalue lambda equal to 1. Next eigenvalue is 6. 6. Now find eigenvector corresponding to eigenvalue lambda equal to 6. Next find okay, lambda equal to 6. As routine procedure, a minus lambda I of x equal to 0. 0 means 0 matrix. A means 5, 4, 2, 1. Lambda means 6. I means 1, 0, 0, 1. Times of x means xy. 0, 0. Now simplify this matrix, we get minus 1, 4, 2, 1, 2 minus 1, 2 minus 6, minus 4 into xy equal to 0, 0. Now we equate the two matrices. First multiply the matrix on the left hand side, we get minus x plus 4y. Second matrix x minus 4y equal to 0, 0. That implies minus x plus 4y equal to 0, x minus 4y equal to 0. These two are same equation. Multiply the first equation with minus sign on both sides. Equation does not change. So second equation as stays. Now you observe that both are same equations. Therefore, here we have only one independent equation. So two times we consider the same equation, no use. Multiple of the same equation gives the same equation after simplification. So we have only one independent equations. That implies here x equal to 4y. If you take any x value or any y value, x value is 4 times of y value. So take y equal to 1. Then x equal to 4. Therefore, eigenvector corresponding to eigenvalue lambda equal to 6 is column vector. In the column, x value is 4 when y value is 1. That's all. You write down any one, enough. So next problem, I will solve one more problem, remaining problem, other problem for your homework. Here I am taking last one. If it is a diagonal matrix, either upper or lower diagonal matrix, we can easily find eigenvalues. Eigenvalue is nothing but diagonal entries. You will see. Solve this problem. So find eigenvalues and eigenvectors. Eigenvalues. In find eigenvalues, first part. Consider A minus lambda I equal to 0. CR equation, characteristic equation. CR equation of the given matrix. Characteristic equation of the given matrix is this one. So substitute A value. A is a 3 by 3 matrix. So first row of the 3 by 3 matrix is 3, 1, 4, 0, 2, 6, 0, 0, 5 minus lambda. It is a 3 by 3 matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. Det equal to 0. So simplify this det value or find the det value. Only diagonal elements only change. So we expand this matrix by using second row is better because already 2 entries are zeros, or otherwise product of the diagonal elements. No need, don't worry. You expand by the first row, no problem. 3 minus lambda times of 2 minus lambda 0, 0, 5 minus lambda. Or first column 0. Remove this row and corresponding column, row and column. We get 1, 4, 0, 5 minus lambda plus last row and the last column. Remove last row and first column. We get 1, 4, 2 minus lambda 0 equal to 0. Now what about this det value? Last two terms zeros. Here 3 minus lambda, 2 minus lambda, 5 minus lambda equal to 0. So lambda equal to product of the three factors is 0 only when any one of the factors is 0. Or lambda equal to 2 or lambda equal to 5. Therefore the eigenvalues are the eigenvalues are eigenvalues are 2, 3, 5. Because it is a 3 by 3 matrix, we have 3 eigenvalues. Now find eigenvectors corresponding to 1 by 1. So first I find eigenvector corresponding to 2. Remaining I give a homework for you. Eigenvector corresponding to lambda equal to 2. Corresponding to eigenvalue lambda equal to 2. So as per procedure, first step is A minus A means 3, 3, 1, 4. Here 0, not sorry, 6, here 6. I put 0, unfortunately. Anyhow, we get a same det value, but replace it better. 3, 1, 4, first row. 3, 1, 4, second row 0, 2, 6, third row 0, 0, 5. Minus A minus lambda I into x equal to 0. First step. That implies substitute A value. Lambda value is 2. I value is 1, 0, 0, 0, 1, 0, 0, 0, 1 into x value x, y, z, because here we have 3 by 3 matrices, so we take 3 variables. If you have x1, x2, x3 also you can take as you wish. Now simplify this equation. Diagonal entry only change 0. This diagonal is 0, 6, 0, 0, 2 minus 1. Here 5. 5 minus 2 is 3 into x, y, z equal to 0, 0, 0. So that implies x plus y plus 4z equal to 0, first row from the first row. From the second row, 4z equal to 6z equal to 0 into x plus 0 into y. Here 1 into 1 into here 0 into y plus 6z equal to 0. And from the last equation, 0 into x plus 0 into y plus 3 into z equal to 0. Now, from the last two equations, z only involved. So that means, therefore, from these two equations, z equal to 0. Substitute z equal to 0 in the first equation, we get x plus y equal to 0. That implies x equal to minus y. By taking y value, we get x value. Z always 0. Therefore, take y equal to 1, we get x equal to minus 1. Therefore, or hence the eigenvalue corresponding to eigenvalue lambda equal to 2 is xyz. Now, x value is minus 1, y1, z0. That's all. We can verify our eigenvalue is right or wrong. Hint, verification, ax equal to lambda x, whether it is true or false. A means 314026005. This is given A. Now multiply with our x value. X value is minus 110. What happened? Whether we get a right hand side value or not. After multiplying this, we get minus 3 plus 1. Minus 3 plus 1 means minus 2. In the second row, we get plus 2. Third row, 0. Take 2 is a common factor. It is written as minus 110. It is in the form 2x. Lambda nothing but 2 into x. Therefore, our answer is right. You can solve, we can evaluate other eigenvalues also. This is homework part. Try yourself. So I am going to another important topic, Cayley-Hamilton theorem. Every square matrix satisfies its characteristic equation. That's all. That is the statement. Statement is enough. This is called characteristic equation. In place of lambda, replace with the matrix A and apply the matrix operations. We get a LHS equal to RHS. That is the process. Cayley proved the theorem after finding square matrix. After finding characteristic equation, substitute lambda value with the given matrix, we get a LHS equal to RHS. That means the square matrix satisfies its characteristic equation. So first problem on Cayley-Hamilton theorem. Cayley-Hamilton theorem. Other part is your homework. Many times we saw the names Cayley-Hamilton, graph theory, in network theory, this Hamiltonian graph, Eulerian graph. There are many concepts they proved in calculus, also in mathematics especially. So anyhow, so verify Cayley-Hamilton theorem for the matrix. Find also its inverse. So Cayley-Hamilton theorem, I mean characteristic equation, is also used to find inverse or find some exponent like that. So here we are going to see all the things. So no need to find eigenvectors in this problem. Characteristic equation is enough. No need to find eigenvalues also. Just we find the characteristic equation answer. After finding characteristic equation, just substitute lambda value in place of A. Now, this is one of the problem. Characteristic equation, CR equation. Characteristic equation of the given matrix. A equal to given matrix. A value is this one, 2, 3. A is A is A minus lambda I, whose det equal to 0. Substitute A value 1, 4, 2, 3 minus lambda times of lambda we don't know. It is arbitrary quantity whose det equal to 0. 1 minus lambda 4, 2, 3 minus lambda equal to 0. Now the det of the matrix equal to 1 minus lambda into 3 minus lambda minus 8 equal to 0. From this we get lambda square minus 4 lambda plus 3 minus 8 equal to 0. That implies lambda square minus 4 lambda minus 5 equal to 0. So this is the characteristic equation, CR equation. Now substitute A equal to verification, verify Cayley-Hamilton theorem. Cayley-Hamilton theorem. The characteristic equation, take LHS, simplify the LHS so that RHS in place of matrix. A square 4A, replace lambda with A, minus 5 times of, you take I, 5 into 1. 5 into 1. 1 is replaced with identity, lambda is replaced with A. This is 1. A value is, you know, what is A? 1, 2, 1, 4, 2, 3. 1, 2, 4, 3. 1, 4, 2, 3 whole square minus 4 times of 1, 4, 2, 3 minus 5 times of 1, 0, 0, 1. Now simplify this. One, 4, 2, 3 into 1, 4, 2, 3 minus 4, 16. Enter the constant inside the matrix, then it multiply all the entries. 8, 12. Here also same thing. 1 into 5 into 1, 5, 0, 0, 5. 0 into 5 is 0. That's all. Now multiply the first matrix. 1 into 8, 9. I am writing directly. 4 plus 12, 4 plus 12, 16. Our ultimate goal is to show that this matrix is equal to 0 matrix, our resultant matrix. 2 plus 6, 2 plus 6, 8. Then 8 plus 9, 17. Minus adding these two matrices because both have negative sign. 4 plus 5, 9, 16. Take minus is a common and adding both 8, 17. Subtraction of two matrices. 9 corresponding entries are subtract. 9 minus 9, 0. 16 minus 16, 0. 8 minus 8, 0. 7 minus 7, 0. Equal to 0 matrix. Therefore, verified the characteristic equation. Cayley-Hamilton theorem. Verified the Cayley-Hamilton theorem. Now, next part in the same question is find A inverse. That is what we get. A square minus 4A minus 5I equal to 0. We want to A inverse. So multiply with A inverse. This is our Cayley-Hamilton theorem equation. Multiply with A inverse. We get on both sides A inverse of A square 4A minus 5I equal to A inverse of 0 matrix. 0 matrix into something equal to 0. In the left hand side, we get A inverse AA. 4 into 4 constant, you take a common out. Here also same thing, A inverse into identity matrix 0. This is identity matrix. Identity into A equal to same matrix. Here identity matrix 4i. Here 4 into identity matrix into any matrix equal to same matrix. So from this you get A minus 4i equal to 5 into A inverse. Keep A inverse in one side. Minus 5A inverse equal to 4i minus A. Now divide with A inverse equal to minus 1 by 5 times of 4i minus A. That's all. No need to find A inverse value. A inverse in terms of A. If you have any doubt, you can verify these two are equal or not. Directly find A inverse, AD minus BC, interchange B diagonal values and take other values as it is with minus sign. We get A inverse. So another part is over. A inverse. Next, we want to express A power 5. Consider this expression as a linear polynomial. Linear polynomial means in terms of A's only. Don't in A squares. Only A's. Okay, that means factorize this. Already we know A square minus 4A minus 5i equal to 0. Keep in your mind. So always converted in this form. You take here A power 5, A power 4. Take from this, you take a common factor. What we take a common factor is better. A cube. It is written first, you see, easily simplify. A power 5, 4, A power 4 minus 5, A cube. Minus 5A cube minus 2A cube, because 7 is written as sum, two terms, because here we have a 5, then take A cube in the first one, plus in the second part we have here 10. We always reduce 2 times. Here you write down 8 times of A square. I can give a clarity. 8 times of A square. Why I am returning remaining 3 A square 3 3A square 11 I split into 2 part. 3A square so here we have minus A. So take minus here plus take minus A is written as how we can return. We need 2 is a common factor, then we get a 5. So 10 A minus 11A as it is minus 10i. So now by the practice only you can understand. Otherwise you simply, if you have any confusion, just simply A square 4A minus 5i. A square is this one. What about A power 4? In this manner also you can evaluate by applying a distributive property, other things. Here my suggestion is, this is also one of the method. So A cube common factor, we get A square minus 4A plus I. 5i. From the first two terms. From the other, these three terms, we take minus 2 as a common. Minus 2, a is a common. We get a square minus 4a. 2a, 4a becomes 8a square. In this term, minus 5i. So remaining terms are 3a square, 11a plus, either plus or minus minus 10i. So first, in the first part, a cube into 0 minus 2a into 0. Now here also we can make in the same way. So 3a square. If you take a 3 common factor, we want to get 4. That means you take 12a minus 12a. 3 is a common factor. We want to make here 15 because 5i is required. 15i. Now we add whatever. So here we added minus 2a. So plus 2a. Here we added minus 5a. So you add plus 5a. So this 0, this is 0, only left with these 5 terms. Now once again simplify these first 3 terms. Take a is a no a. 3 is a common factor. We get 4a minus 5i plus 2a plus 5i. This value is 0. 3 into 0 plus 2a plus 5i. That implies 3 into 0 equal to 0. 0 matrix into 0 equal to 0. Here not ordinary multiplication, matrix multiplication with a scalar. 0 matrix into some other matrix equal to same matrix. That's why here we left with 2a plus 5a. What is the exponent of a? 1. So it is linear. Stop. Don't keep square, cubes, higher order. We always converted into linear model because here they are asking converted into linear. That's why I converted. Otherwise, no need to convert. So this is the eigenvalue type problem. So here I provided another problems also. Try yourself. Here I provide the other problems, other 3 problems. Try yourself. Same manner you can evaluate. Okay. I stop this concept.